Hello. And so, what we're going to start working on now, I'm going to warn you, this is pretty hard. Okay. Anytime that we have to solve problems in the real world, that really means word problems. And so, I want you to take your time with this, do your best, go back and review other lessons if you need to. And we're going to work on this and do our best this week. I have some practice worksheets that I may also make videos about just so everyone can kind of work at their own pace because like anything else, some of us are going to catch on and maybe move a little faster than others, and that's okay. I found some example questions that are going to be probably at a level 2.5, so that B plus range. And so if we can't be successful, all of us at the 3 or the 3.5, then we'll be happy with the 2.5 on this skill. Okay, so we're going to get started on page M3 135. And this is also one of my small groups, if you have me for intervention. And so we are looking for the quotient by dividing. Okay, now this is a skill that we can always work on. Remember, the first number goes inside the house, the second number goes on the outside of the house. Okay, now I love dividing by 25s because I think of quarters. So if you don't know what I'm talking about, you can always just keep adding. There's 125, there's two 25s. I can add 25 again and get 75. That's three 25s. Now, if you know that 3/4 is 75 cents, then you can skip that part. I'm using this organized list to then help me think about how many 25s are in 43. Well, I can see 1 is 25 and 2 is 50. So if I did 2 of them, that would be too many. So I'm going to put a 1 above the 3. I know that 1 times 25 is 25. I subtract. Got to borrow there. So 13 take away 5 is 8. That 4 becomes a 3 because I borrowed. 3 minus 2 is 1. Now, we're not done yet. Okay, we got this 5 hanging out over here. We have to bring it down. Now, I can tell from my list over here that 3 25s is not going to be enough to get me to 185. So I'm going to add another 25. So 4 of them is 100. I kind of ran out of space. So I'm going to move over here. That's 4 of them. There's 5 of them. Whoops. There's 6. Now, I can see that 175 is really close to 185. So I'm going to stop there. I put the 6 up here because that's 6 25s. And I know that 6 times 25 is 175 because I did the repeated addition. And I know that I have 10 left over. Now, some of you might, your level is going to be to stop here and say, oh, I have a remainder of 10. But some of us, especially as sixth graders, we're going to start working with decimals, or we have been working with decimals. So if I put the decimal here, I can add what we call as a trailing 0. And look what beautiful thing happens now when I bring that down. I have 100. And if I do recall, 4 25s is 100. So I can see the answer is 16 and 4/10. So you guys do your best on the other two. Let me check them. We can check them with the calculator and just see how you did. It's really good practice. Now, where we're going is target 2, our algebraic equations. This is our last target on this, and we have to write and solve algebraic equations representing real world problems. So we're solving word problems, okay? Our target or our learning goals is here on page M3 135. Remember, our goal is to get to that level 3 skill. Now, we might touch on what a literal equation is. It's not really in our target. It's just kind of extra, okay? You know how we like to have extra sometimes. Page M3 136, we said that we see the definition of a literal equation. So let's write here, what is a literal equation? Oh, it says some of these equations are literal. Literal equations are equations in which the variables represent specific measures. You most often see literal equations in formulas. Now, you guys may not realize it yet, but you've worked with formulas. This is the formula for the area of a triangle. Remember when we took the base times the height and then we divided it by 2? That's what this is. And those equations that never change, we also sometimes call formulas, and they are literal. Nothing we do is going to change how to find the area of a triangle or how to find the area of a rectangle. Those are always going to stay the same. We call them literal. Okay. Now, there's really nothing leading to this concept, so we just jump in with practice problems. Okay. We're on page M3 137. Okay. Raul's sister is 6 years older than he is. What is Raul's age if Raul's sister is 19? So we got to think about this, okay? The first thing that I'm going to do, we kind of call this defining the variable. And when we get into independent and dependent variables in a little while, you're going to be glad that you kind of hung on to this when I said define the variables. We're basically going to talk about what we know and what we don't know. Okay, so I'm just going to use R, okay, for Raul's age. They never told me how old he was, but they want me to find out. Okay, what do I know is Raul's sister. What do we know about Raul's sister? 6 years older than he is. Okay, so we're going to have Raul's age, which I'm using an R, and it says that his sister is 6 years older. How can I show that in math? Remember, in math, we're either going to add, subtract, multiply, or divide. And I think when somebody's older than you would want to add. Okay? Now it says Raul's sister is 19. So that means that Raul's sister, her age right here is 19. What does that equal? Well, it equals the expression that we just wrote. And you guys just learned in the last section how to solve this. Okay, so we want to think about getting R by itself. What's the opposite of adding 6? We subtract 6. So we know Raul's age is 13. 13 years old. Okay, so step by step by step. I have a little helper over here. Luna. Oh boy, here she comes. You going to do the math too, honey? Okay, we'll see how that works. Okay, let's take a look at the next one. Approximately, that means about 1/10 of the mass, that's how much space you take up, of a medium-sized apple is sugar. But it's all natural sugar. What is the approximate mass of a medium-sized apple that contains 19 grams of sugar? So I'm going to start at the beginning again. I'm going to define my variable. Wait a minute. That should be an F. Luna, honey, I wouldn't chew on the electrical cord. So we're defining the variable. So I'm going to use M for the apple's mass. And it says 1/10 of the mass. Okay. Okay. 1/10 of the mass is the sugar. Is sugar. So I hope that you guys remember those words that I told you about. Of is multiply, is means equals. Okay, we did that a long time ago. So the 1/10 of means multiply. The mass, which I'm saying is an M, is sugar. That's the amount of sugar. Okay. Now, what do they tell me? They're asking me for the mass. That's why I defined that as my variable. If what? If the apple contains 19 grams of sugar. Okay. So 19 grams of sugar is going to go here with the sugar. So instead of the sugar, I'm going to write 19 grams, 1/10 of something, the mass, equals the grams. Now, 1/10 times the mass, so we want to get the m by itself, so the opposite of times is, you got it, divide. So we have to divide by 1/10. Okay, so I'm going to move up here. I'm going to change colors so you can see where I'm going. And I'm going to do 19 grams divided by 1/10. That's the math I need to solve. So remember, we did keep, change, flip. 19 stays the same, but I'm going to write it over a 1. I change division to multiply, and I flip this fraction upside down. And I love it when there's ones down here in the denominator, because ones, when we multiply across, anything divided by 1 is just itself. So those can just kind of float away, and all I have to worry about is taking 19 times 10. And that gives me the answer. 190 grams is the mass of the apple, because 1/10 of it, 19, is sugar, and that's what we were told. Okay. Okay, let me see how much time's gone by here. Okay, we probably have time to do one more on this video. Oh boy, Oscar's making brownies for his class. He tripled. So right away, you got to think about, what does triple mean? Triple, double, triple. Remember, try means 3. So that's going to be times 3. He tripled the recipe he normally uses. If he made 36 brownies for his class, how many brownies does the original recipe make? Well, this one sounds a little easy, doesn't it? Okay, so we can define the variable. We can use B for number of brownies. So we're kind of following the same steps, even though some of us might be able to go, oh, I can do this mentally. I know what math to do mentally. Now, how many brownies does one recipe make? Or let's talk about, how are we going to triple the recipe? We're going to take B, the number of brownies in one recipe, and what do we have to do to that? We got to triple it. So how do we triple it? We would multiply it times 3. And remember, we can smash those together. Okay, we can smash them together. That means multiply. So now we know the number of brownies, don't we? 36. So now we just have to do the math. So 3 times B is going to be 3 times 36. And we can work that math right over here. I'm going to change to blue so you guys can see my train of thought. We're multiplying. 3 times 6 is 18. Carry the 1. 3 times 3 is 9. Plus the 1 is 10. So they have 108 brownies in that recipe. Nice job. Okay, I'm going to go ahead and end this video there, because like I said, this is just more practice, practice, practice. You guys try number 4, number 5, and number 6. Okay, and then I'll come around and check. And you know what? If you get any of these, look, you're already at a level 3. This is where we need to get to. Okay, now I see decimals in this one, so if you need to, grab a calculator. Okay, good luck.